guidance from Dr. Wankar sir. So all the best to all of you. Hope the next 2 days will be knowledgeable for all of you. Thank you. Thank you very much. Now I request Wankar sir to proceed further.
Uh, Thank you, Gawande sir, for your brief about the IEEE Program branch and our department. Now, I request our student speaker, Mr. Hannan Satapai sir, to start with the session. Before starting the session, I would like to introduce him. Mr. Hannan Satapai is presently working as a chief AI scientist at Empowerg. He is the secretary at Training and Technical Planning and Activity Committee of IEEE Bombay section. He has a vast uh, experience in AI, data science, then Alexa development, then full stack development, IoT. He's also working as a Tinkercad advisor to Autodesk. He is one of the IEEE speaker in IEEE Bombay section. So I'm having a wonderful experience in the IoT and the allied areas. So without much wasting much more time, I request Mr. Anand Satapai Saji to start with his session. Sir, please.
Okay, great. Good morning, everyone. I hope I'm audible to one and all.
Yes, sir, you're audible.
Okay, great. So I hope you are all doing well. I'll just take over the whole thing and then guide you all towards how we can use Tinkercad for working with Arduino and Internet of Things. Before we get started, let's get very comfortable with all of this. Let's take you know deep breath and let's continue ahead with this whole thing. All right. So what is Tinkercad? Why do you need Tinkercad? What do you mean by simulation? Let's get this all cleared up first so we are all set for this workshop. And I want this workshop to be very interactive. So if you have any concerns or doubts, then you can always type in the chat and let me know. So as you have already been spoken, because of this pandemic, you are not able to access devices such as Arduino, Raspberry Pi, Node MCU, and so on, because of which we are in kind of like a lag, because of which we are not able to do the development. Now how to solve this? There are multiple solutions. Of course, simulation softwares like multisim exists, but typically what have been the problem with such softwares are, even though they are very powerful and used in the industry, it's not very beginner friendly. I mean, I have been myself from the electronics and telecommunication background, and I know for a fact that using this software takes times in practice. But this is where Tinkercad comes in. So it's more like a visual drag and drop simulation software, which you can utilize for performance simulation of hardware devices, including Arduino. There are more microcontrollers being added from time to time, and the plan is for Autodesk to cover as many ranges as possible. But now the list is also quite comprehensive that we are also going to see. So it just simplifies the whole development. Like imagine I want to make something which like auto night lights, or something like mood lamp, which is controlled by the Internet of Things. Okay, so for that I first will need to, let's say, purchase Arduino, purchase some hardware components and stuff, do the coding. This will take time, and procurement, there is a cost attached to that as well. Tinkercad eliminates all of that. By allowing everything to be online, you can simulate, you can test, you can see how things are working, do the tweaks and changes, and if everything works out, you can, order the whole device. You build confidence in yourself that the device is working as expected, and then you can go in the market, get the device, and get that thing working. So first stage is simplified, which is a simulation. So there is no cost involved to you. It's completely free. There is no time you require for ordering and so on. At the same time, we all make mistakes. So some things can go wrong here and there. We have blown so many LEDs in colleges, right? We know that. Now there is no blowing of of LEDs now, because it's all online. So even if you make slight mistakes, even if you do the wrong connection, you will know that. If there is a power difference, you will know that. And there are so many things, let's say, multimeters and voltage regulators and so on, which are available on Tinkercad itself, that will allow you to do more than just simulation. You can get power analytics, you can see so many things which will allow you to be a better designer and make better products. So if that is all clear, let's go ahead to the platform without any further ado. So I'll be sharing my screen right now. Okay, so here it is. So, okay, before we get started, if you want to sign up on Tinkercad, all you have to do is go to tinkercad.com and you can sign in with your single sign-on of Google or Microsoft, or create an account if you wanted. So, yeah, so this basically is the 3D part. So Tinkercad just don't allow you to do circuit designing. It also have 3D designs as well. If you are interested in that, that's something that you can pursue as well. These are some of the designs I've done before. What you need to do is, this is a Tinkercad dashboard. You can go to circuits over here, and this is where you will be creating the circuits. You will find your previous created circuits over here. But first, what you need to do is, yours might more be empty because you're just getting started. So what you have to do is, you can click create new circuit, and you will be taken to the dashboard, or to the play area, I like to call it, because we play around, tinker around, as we like to call it over here. Okay, so this is the play area that we have. We can have all the fun we want over here easily. uh, Before we dive in and start the games, if we want to call it, just wanted to have all of you to have a very simple idea about, let's say, electronics, or IoT. So how this works is, let's divide it into a couple of modules. So there are input modules, there are processing modules, there are output modules, and there are connectivity modules. Basically, you just need to know this four things. So your device, your component will either belong to any of these modules. So it can be like input module, output module, processing module, and connectivity module. Let's take in some example of this module, so it's all clear in our head ki what we are doing and what everything is. So designing becomes super simple and super fun. So input devices can be, let's say, push buttons. It can be, let's say, your regulators that you see to control your fan. It can be, let's say, your microphone, where it's an input device. It's capturing the input. Anything which captures the input will come under the input device. It can be light sensitive resistors, or light dependent resistors, LDR. It can be ultrasonic sensors. It can be vast variety of it. Usually input devices are also known as sensors, as you might have already understood. Now there are output devices. You have output devices such as LEDs. Of course, LEDs, with LEDs you get bulb, you get fan, and all of that. You have relay. So through relay you control big appliances. You have motors, because through motors, I mean, you can create so many things. In fact, the whole, if we consider Tesla car, the whole car itself is an output device, where the wheels are basically the motors which are rotating because of the electric current. So that's the output device that we have. Apart from that, we have piezo buzzer, we have RGB LED, we have LCD. So all of those are output devices. Some of those output devices, such as motors, are also called as actuators. So that's a technical term if you want to go with that as well. Now there are, of course, processing devices, or also known as microcontrollers or microprocessors. So it can be like Arduino, it can be Node MCU, it can be Atmega, or Atmel, or it can be Texas Instrument devices, it can be Raspberry Pi, it can be Intel Edison. The whole goal of the processors are to take the input from the input devices, do whatever processing is required, add your logic, and then give some output. to the output device. So that's the whole goal of it. So you can build a custom FPGA or go with Arduino. Anything is fine, whatever works. Then the fourth kind of a device that you see are the connectivity devices. So connectivity devices are, for example, Bluetooth, which is a connectivity device. So you connect it with HC05, which is a Bluetooth module. Then you have different, for IoT, you are connected to the internet. So you have Node MCU or you have ESP8266 and so on. Some devices are some microcontrollers come pre-configured or pre-added with such connectivity devices, such as Raspberry Pi, which have Wi-Fi as well as Bluetooth and all the others, inbuilt. You have other devices such as LoRaWAN, which is for high range communication. You have antennas and so on and so on. So the whole goal of this connectivity devices is to transfer the data from the processor from the edge. Let's call it edge. Edge means the hardware device itself, to the cloud or to some other machine. So it can go to the cloud. When it goes to the cloud, you can consider it as IoT, Internet of Things, because it's going on the internet. If it goes to a machine, then it's machine to machine communication. If it directly goes on your phone, let's say via Bluetooth, control through Bluetooth, then it becomes like another kind of application that can be application of Internet of Things, but with the Bluetooth communication protocol. So these are some of the basic things that you need to know, and I hope this clears any confusion that you might have. So it's basically very simple, just four things you need to know, and if you know that, then you can do almost about anything in electronics and IoT. So now let's, since this is all in the clear and everything is understood, let's understand the play area first, the playground first. So there are a couple of things over here. I usually recommend you selecting all components from over here, so you are able to see all the components that are available in Tinkercad. You have general components, you have some input devices over here. So you have slide switch, you have photoresistor. So they have conveniently grouped the devices together in categories, so it's easier for you to get that information. So lots of sensors over here. You have keypad, you have DIP switch, you have gas sensors, you have PIN sensor. PI sensors are like motion sensors and so on and so forth that you can utilize. You have output devices, which are LEDs, NeoPixel, you have vibration motor, you have DC motor, you have servers, piezo buzzer, 7-segment displays, LCD, and so on. Of course, for power, you are going to use some kind of a battery. You have breadboards, you have different microcontrollers. So currently you have Arduino, you have AdTiny, and you have the microbit microcontrollers. So these microbit microcontrollers have been added very recently. So if you want to experiment with that, then that's also very possible. Then, like I said, there are instruments such as multimeter, function generator, oscilloscope, and power supply that you can use to take your development game up a notch. So you know how to see the power consumption, optimize it, see different values of resistors and inductors, how it affects everything, see power consumption across different inputs and outputs, so that you are able to make the best decision. And you, of course, you have ICs, 555, 556, couple of those, power controllers, connectors, logic gates. So these are all the components that are present in Tinkercad. We'll not be going through all of those. We are mostly focusing on using Arduino and then interfacing it with input and outputs, sensors and actuators to make some magic happen. So let's search Arduino over here, and the way that it works is you can drag and drop over here like this. You already have some starter kits which are available that you can use for different purposes. So let's start with a starter kit. So we have a starting slate to work on. So I'm just going to drag and drop this over here like this. So you have the Arduino with you, you have the LED with you. If you want to change, name it something or change the color, then you can easily do that according to your choice. You can also change the value of registers, so depending on what you want, you can experiment with that. Of course, as you might know, LEDs always go up with the register, otherwise they will end up blowing. Over here it will not blow, but it will give an error. uh, as we know the connections, the cathode is going to be connected to the ground, and the anode is going to connect it to a pin or the output pin through the going through the register. So it's obvious that most of you will know about the Arduino, but let's quickly iterate. So here are the power pins. So you have 3.35 volt ground VN. You have the analog input pins. So analog input pins are which can provide analog data to you. So they are only used for inputs. Analog data can be, let's say, from a microphone, which is an analog data. On the top you have digital pens. So these digital pens are capable of both input and output. So depending on which mode it is set to, you can make it take the input or give an output. The PWM basically stands for pulse width modulation. So 11, 10, 6, 5, 3. These are pulse width modulated pins where it's very useful to give an output where you are able to change the width of the pulses, so to create some kind of effect. So it's very useful in piezos because it's able to, by changing the width of the pulse, it's able to create different sounds effect through that. And then of course you have the 0 and 1, which is the TX and RX pin, which is usually useful for communication with other devices, which is based on SPI, serial transfer protocols, or also usually used with the internet connectivity devices or the connectivity devices such as ESP and Bluetooth module. In the top you have one more ground pin, but okay. So that's all what you need to know from all of this. One thing is it also have a light connected on pin number 13 by default, so it's useful for debugging purposes as well. Now, how to code this, right? The main thing is with Arduino, you need to do coding through embedded C platform to make the things work. To code it, you can go to this top bar and click code. So you have couple of options. You just don't need to go directly on the text-based coding. You can have multiple coding options such as blocks plus text, or just text. Over here, this is a block method where you are doing a drag and drop and building up your system. So this is very useful if you're just getting started, and this actually the Tinkercad platform is used across the world internationally by to teach kids electronics as well. So for them it's very useful to use the blocks of simple circuits. So the circuit is quite simple. Set built-in LED to high, pin number 13, which is the built-in LED to high. Wait for 1 second, then turn it low, wait for 1 second, and it's just basically going to keep this loop repeated, and just going to repeat the whole loop. You have couple of options over here. If you see, you have a way to take the input, you have a way to take the output, perform control by waiting, repeating. uh, you can perform some math and comparison. You have variables. Notations are just for comments. So if you're just getting started, then this is quite neat as well. But let's stick to text for now because like we are engineers, so we should stick to this. So we have two basic things that you need to know. You have void setup and you have void loop over here. So setup is something where you initialize your variables, you add, do the initialization, basically any initialization, making a input or a port, input output, and adding any other variables that you will like. And then in the loop, it's something that is going to be continuously or repeatedly repeated over the period of time. So simple code over here, we have pin mode 13 as an output because of course LED is an output device, so it's an output. You are running a loop. So to give an output through an Arduino, what you can use is you can use the command, you can use the function digital write. it takes two parameters. One is which is the pin number where you want to give the output, and what is the output that you want to give. So it can be either high or it can either be low. Then you add a delay. So basically delay adds like a wait time. So it's in milliseconds, so consider that. Then you do a digital write, and you can then turn it low again, and then you add a delay of 1000. So it's basically very simple. So it goes high, wait for 1 second, it goes low, wait for 1 second, and then it keeps on repeating it. Let's start the simulation. So what you need to do is you can close this, so it does not come in between, and you can click start simulation. And then you can see over here these LED is blinking after every 1 second with a delay of 1 second. As simple as that. Like, it's so simple. You don't have to worry about purchasing anything. You don't have to worry about connecting anything. You don't have to worry about anything going wrong. It just works. You don't have to download any IDE, works with any library and so on. It's just as simple as that. All you have to do is drag and drop, connect the components, write the code, and start simulation. It just works. You see how simple it is. And slowly we'll build on this system to see, even though it's a simple system, you can build complex circuits with the help of this ecosystem. So I hope this gets you excited to get working on this, and without any further wait, let's get ahead on this. So I'll stop the simulation. I'll go in the code. One minor change that I really like to do is work with variables, because that's a life savior. Usually I like to write my variables on the top. So that's something that you can also follow if you want. So you can write int LED equal to 13, and then it will basically initialize the variable with the name LED to pin, and provide the value 13, and then I can just replace it over here. And then I can click start simulation, and then it just works. The benefit is, with all the data being stored in a variable, if I want to connect it to some other pin, it's very simple, and it's very useful, especially when you're connecting multiple devices, or you are connecting you can say multiple output devices, to control them with LED with variables very easily. So that's a simple thing. Using a variable, we'll try to use variable as much as possible. So over here, what we covered is the using of the microcontroller, as well as the output device, which is an LED over here. What you can do is, of course, you can add just a second, I'm opening one circuit. So okay, in the meantime that opens, adding more LEDs is very simple. So I can just take this, I can just copy paste it over here, and just paste it over here, connect it with ground. So okay, to change the color of the wire, you can just click on it and do it. Color coding is usually good, so you don't make any mistakes ahead. I go in the code, I make one change, which is this. This is connected to pin number 8 over here. Don't forget, it's very important that you do like a pin mode of this, and make sure that Arduino knows that it's an output device. Let's remove those comments. I know you already know what this is, so I'm not going to add those. So I'm just going to do this, and then of course do a copy paste. Let's put 2, let's put 2, let's start. So what happens basically, it's going to start, hopefully it will start soon. Okay, so LED first blinks, then LED2 blinks, and so on and so on. It just keeps on repeating itself. So it's like a loop that is running over here. But of course, I'll give like a simple solution for this. Instead of using and repeating your code, imagine you have 10 LEDs, and imagine you are wanting to create something fun like this for, let's say, uh, let's say Diwali, like a whole string of LEDs. Then your code will be too huge. Usually, I recommend a simple solution of using arrays and for loops, but we are not going much into coding, so that's not something that I want to add right now. But that's totally under your control, so it's something that you can easily do when you want. So that's a recommendation that you can go with. So adding of more input devices is very simple on Tinkercad. So this is one of the basic, you can say, input devices. Let's go ahead and try to sorry, that's the output device. I'm sorry for that. Let's go ahead and try to see how we can take the input from one of the device, and slowly we'll build up over there. So I'm just going to delete this whole thing over here, and done. I'm going to drag and drop this button over here as well, so you can see how it works. So basically this is the input device, which is a push button. So push button control is very simple. You see push button almost everywhere, and by push button it follows the same logic for you can say anything that you turn in off, like any switch. So it's basically a switch. The connections are very simple. So the connection goes like this. You are connecting the 1A to, let's say, the ground. You are connecting the 2A to power, and you are connecting the 1B to any of the input ports, such as 13 to 0. You can connect to any of the ports that you want. So basically what happens when the circuit is open, what happens, the no connection is made. So the ground and the 5 volt are basically separate. There's no connection that is going on. When you press on that push button, the connection is established, or it becomes like a closed circuit, and the pin number 2 gets receive power, receive voltage. When it receive voltage, what happens in that case, it's basically able to read, the Arduino is able to read that voltage and take that as an input. So basically when it receive voltage, it considers it as 1. When it does not receive voltage, it considers it as 0. So that's the basic of how input devices work. So the input devices, the whole goal of input devices is to somehow provide 0 and 1 to the processor, in which in this case is the Arduino. So the 0 and 1 can be provided through any of the input devices that are available. So there are a ton of those that you can get in the market. Okay, so let's dive into the code. Let's okay. So I feel they have done like a lot of coding in blocks to keep it simple. But again, like I said, we are going to shift to text over here. So first thing first, we need to make sure the pin mode 2, which where this this input device, this button is connected, is considered as an input. Because if you don't do that, then the Arduino will be confused. Okay, the Arduino will not know, okay, whether you need to take the input from that pin or whether you need to give output to that pin. So it's very important. Many people make this mistake. So now you know that you should not do that. In pin mode, you are considering pin 13 as output. Over here, the pin number 13, like I said, is already connected to a built-in LED over here, which you can utilize. Similar to how we have digital write, we have digital read present as a function in Arduino in embedded C. So you can do a digital read. You are reading from pin number 2, and you are saving the state to a variable known as button state. So it's a variable known as button state. By default, it is 0. It is open. There is no voltage flowing through it, no current passing through it. Because of that, it's 0. when you take the input from digital read, and if you have not pressed the button, it will give an output which is 0. When you press the button, it will give an output which is 1. If the button state equal to high, so by 1 and 0, it's a similar analogy to low and high, so you might want to know that. So if the button state equal to high, if it's pressed, then turn on the LED. If it's not pressed, then simply turn off the LED. We add a simple delay to because it's like for the performance sake for the simulation, but you don't need to add delay of course, and when you're doing it in real life. So let's click start simulation, and then simply click it. So as long as it's click, if you see on the left, the light, the LED is on. When I do not press it, the LED is off. So you can, make it blink like this, the way that you want. So that is one of the additional benefit of Tinkercad, where this sensors and actuators or the input and output devices can actually be controlled by you to see in real time how the variation happens. And that is very useful in many cases, because you can do a lot of things when you actually are able to visualize, you are able to see what the input does to the output and how the processing happens. So that's one of the added benefit of this whole system. So that part is clear. We learned how to take uh, the input in a basic format, in a digital format, from one of the input devices, which is a push button. We saw how to control the output devices using simple methods such as digital write, which in this case we were able to turn on the LED through the help of the digital write. So that's the basic of the input, the processing, and the output with push button, LEDs, and Arduino. Let's move ahead and try to create and try to take more complex circuits with this whole thing. One thing I like to do is I use for it's very important that you work with circuits, when you work with microprocessors and controllers, that you are able to debug your circuit, you are able to work with your circuit and then kind of like debug it, see some more information rather than just seeing the input and the output, because at times your output might not directly be controlled by input, it will go through certain processing, and you might want to see those processing before you go ahead and before you go ahead and you okay sorry before you go ahead and you create complex circuits. So it's very important where we will use something known as a serial monitor for for debugging purposes. The serial monitor can also be utilized for taking it as an input as well. So let's go to the code first. One change that I am going to make over here that will allow for the serial. Okay. It just keeps on forwarding. Just a second. Okay, great. So the first thing that you need to put is do a serial begin 9600. So this function is very important to work with the serial. You are basically doing a communication with the serial terminal with doing a perform by adding the code serial begin 9600. So 960 is nothing but a baud rate, or imagine it this way. So baud rate is technically like with the speed of communication and stuff, but let's consider it this way. So the baud rate is very important. It can be anything. There are different variations that are available, which you can easily find, but make sure that the baud rate is the same of the terminal as well as in the code. Imagine baud rate as something like a language. So, if you have selected the language English, which let's say in this case is 9600, then your serial monitor needs to also have the language selected as 9600. Many a times this is the issue of miscommunication where your baud rate are different from each other. It's as good as I'm selecting the language English, but the serial monitor has selected the language Chinese, and nobody will understand anything. So I'm speaking anything and the serial monitor is trying to understand anything, and there's always going to be miscommunication. The best way is to have like a serial monitor, and the Arduino code have the same baud rate, which will not create any issues. But also this is one technique that is utilized to control multiple serial devices on different baud rates, especially Bluetooth, where you are able to select different baud rate for Bluetooth and control that on the same serial terminal, because they both have different timing frequency. Either way, to print something on the serial terminal, what you need to do is, let's say you have to do serial dot print. There are two functions basically. So you have serial.print and you have serial.println, which starts for like new line. And over here you can type something that you want. So hello, but of course we want to show the data. So I am going to type over here button state. So what it is going to do is it's going to read the data through digital read. It's going to save the data in the variable button state, and then it's going to print on the serial terminal. So let's click start simulation. And I am pressing this. It works, but nothing is happening. Where do I see the output? Strange. Oh yeah, I see it over here. Below you have a serial monitor present. To use it, click on it, and it's going to continuously show you the output. When I click it, you can see for certain duration it turns to 1, because it is taking the 1 as an input at that time. When no input is provided, or when I'm not touching the push button, the input that is being obtained is 0. When I push it, the input being obtained is 1. Super simple, super fun to use, but very powerful, very useful, because when you're building complex circuits, your information can go through different stages. There can be complex processing that is happening, and serial monitor is very useful for printing this information. So you can have the variable states being printed, you can have your custom variables being printed, custom data being printed as well. There's also one neat functionality that have been recently added in the Arduino itself. It's from pretty before, but many people don't know, is the serial monitor. So you have a serial monitor. To open the serial monitor, click this graph thing. So basically what it's going to do is, apart from showing the data as the numbers on the monitor, you can also visualize this data, which is great because we learn more. A picture says 1,000 words, and this is a complete graph. So it gives you a lot of information. This is very useful, especially when you're working with accelerometer data and other sensors, other input sensors. So it's very useful. So basically, by just clicking the serial monitor, automatically your numeric or float data is converted into like a plot, and you can have multiple plots as well if you want, and you can see the variation that happens based on your input that you're providing. You can see the output easily on the serial monitor. So I can kind of like trying to create like a square wave over here, but you get the point. So you are able to basically see the timing functions and see when the input was created, and so on and so forth. So it's very, very useful for a lot of things. And serial monitor is going to be your best friend if you are going to utilize it for advanced simulations, or advanced complex codings as well. So remember that this is a neat trick that you can show off to your friends or teachers if you want, where you are able to automatically plot the data. So that's something that is fun and you can do. So that covers the input and the output, the processing, as well as using the serial monitor. Now, what happens basically when you are what we see right now is we are providing a digital output to the LED in the form of 0 and 1, and we are taking the input from the push button in the form of digital read, which is again in the form of 0 and 1. But most things in life are not digital, it's not 0 and 1, it's always analog. So it's like a mountain and valleys, it just goes up and down and every way it can. And most of the sensor devices that you typically see are going to give you data in the form of analog. So let's understand how to take an analog input, which is what we are going to do now. So let's remove this, remove the components, and let's drag and drop this over here. So analog input are pretty simple. So we have potentiometer over here. Some people like to call it regulators that you see for controlling your fans. Yeah, basically they are potentiometers, nothing else. Potentiometers are simple devices. They are variable registers. Nothing fancy going on over here. It's super simple. So basically it's like a long, like imagine it as a long strip of registers with a controller over top. So you go take it from left to right and automatically you are able to control the value of the resistance. Super simple. To get more control, you can click it. You can change the maximum resistance that it can have. So these are some of the things that you can do, but it is actually one of the input devices which are variable, and since it's variable, you can use it to get the analog input over here. Analog simply means something that is not a straight line, but it can change from one point to another. In the analog, the precision of the analog of the microprocessors is important. So little technical part of this. So basically, uh, let's just work on it. Then I'll tell you a little technical part about this analog input. Little technical but fun part. So connections are simple. Terminal to 5-volt ground. You can interchange it if you want. It's as I just said, does not blow up, so it's all good. In the middle of the pin will be connected to any of the analog input pins, so A0 to A5. So this is very important. Like I said, to take the analog input, you have to use pin A0 to A5 only. Let's go in the code. Let's change the block to text. Let's be professional. We are going to add sensor value over here, like a variable by default, which is 0. So we can take the value of the sensor. Pin mode 13 as output. Yeah, well, cool, that's all fine, but I'm just going to remove this extra stuff. You don't need so many extra stuff just to get started with this, right? It's so simple. Let's know output right now. So it's as simple as that. Like imagine it's like few lines of code. That's almost are like curly brackets. So yeah, so it's a simple code. The setup loop. Setup, you are saying the analog input devices as input. So one hint or one tip, you for analog inputs, you don't need to say to Arduino, hey, this is an input device. By default it's an input device, it's not used as an output device. So you don't need to do that, but it's a good practice if you do it, because everything is clear, which are the pins which is being utilized. So it's a good practice, but it's not compulsory. But for digital read and write, it's compulsory, so remember that. Let's run a loop. Similar to the digital read, we have an analog read, such a simple function over here. We are going to read from A0, which is pin A0. We are going to save it over here as a sensor value. Okay. Now I'll save it, but how will I know the value, right? I mean, what even is the value? How will I know that? I'm not connected to any output devices, so I cannot see the output. How I'm going to see the output? Well, I can always use a serial monitor over here. So I'll just do serial begin, and I'll do oopsie being human. And then I'm just going to do serial dot print ln and sensor value. Over here, just make sure you don't make spelling mistakes with your variables. I see a lot of people when I take workshops, hands-on workshop, when I used to actually, that people making a lot of mistakes in the variables, making the wrong name of the variable. So that's important. I'll click start simulation over here, and So it also have like debuggers and so many other things where you can include libraries. You can download the code if you want. You can include libraries, external libraries, which is very very useful if you are interfacing with some other devices, creating your own libraries, and then have a debugger where it's like a point to point, step by step debugging. But let's not go into that right now. Let's open the serial monitor, and by default I am seeing a value of, let's say, 511. Okay, I am just going to click this and I'm going to vary the knob. As I vary the knob, I can see the changes happening on the serial monitor. Basically, I am changing the output. Sorry, I'm changing the input. I'm changing the resistance of this potentiometer, and because of the change, the resistance of this potentiometer, I'm able to see a difference in the reading. So basically it goes from 0 to up to 1023, or if you are following a one index format, then it goes from like 1 to 1024. Why 1024? What does it even mean by 1024? So any calculation aside, basically what happens, it's basically the precision of that analog sensor. It's basically the precision of that analog input that is present on the Arduino. So if you see, basically it goes from 0 to 1024. If we consider a step size of 1, then it, let's not go in much technical, but you can say there is a precision, the of around 1 because of the step size of 1. So it's able to detect a change of step 1 in the, in the input. If you usually go with more higher end microcontrollers, they have more precision, where the step sizes varies, where the step size, because of that variation, you are able to get more precision. So even a minute change in the input can be used to trigger different things. So it's very useful in production environment and industrial environment, where you go for microcontrollers which are having more precision on the analog inputs. But this works for our purposes. For many general purposes, you don't need that much precision. You just need to use like something like a threshold. So that's all good. And basically what it does, it goes from ground to 5 volts. It's basically dividing the value, the actual value that you get into multiple parts based on the step size and giving you the output. And like the one neat technique that you can use for this serial is the serial plotter. And then like you see, by varying this analog input device, you are able to see the graph, how it comes up, and so on and so forth. So yeah, pretty much good drawing tool if you ask me. Yeah, but it's a pretty neat technique that you can utilize for seeing the output. And once you see the output, you can take screenshot and utilize it to support your your project and so on. And you can use this for a lot of use cases, for a lot of purposes. So this serial plotter along with the analog input is something that you need to know, have it in your toolkit. If you are Batman or Catwoman, then you can definitely add it to your belt of gadgets. Pretty much very useful. So you have the analog inputs over here, and you see how you can use this for checking on the serial how things work and plot it out. Pretty simple, right? It really is. Let's go ahead and let's learn how to give analog output. So we learned how to do digital read, digital write, analog read from the input device. Let's see how we can do analog write in simple sense, if you want to call that, to an output device to control an analog output device. So I'm just going to remove this and remove this and remove this. Just going to drag and drop this servo over here. Okay, just waiting for it. Let's start the simulation first, see the output, then we talk about it. I click start simulation. And what happens, this basically output device, which is a servo motor, and use it in many complex robotic devices and cars and so on is being controlled, and it's rotating in different angles, which is controlled by the code we are going to see soon. Let's stop the simulation. I'm going to connect this to pin number 8. I'm just going to change from pin number 9 to pin number 8. I'm going to click start simulation. Whoa, it's not working. What happened? Is the code broken? Did I break something? Let's change the wire. Let's connect it to pin number 6 and click start simulation. Oh, of course, yeah. One more thing, if I change the, oh, I have to still change the code. First thing, yeah, you have to change the code. You cannot just directly make changes to the, the wire and it will work. Let's go in the code. I'm just going to, um, uh, let's go text. I don't really like. I'll attach it to pin number 8. I'm changing, so it's a variable, so it's all code. Just checking, and then I'll click start simulation. Okay, it does work. Cool, great. But just remember, one thing. Like I told you, there are these PWM devices or inputs that you need to have, because of which you are able to control the pulse width of that hardware of the the output, and then you through that you are able to control so many more things. I think we are going to see that in when you go with piezo buzzer, where you are able to create the melody. But one thing that you need to know is, typically when you work with analog outputs, try to connect it on the PWM, because it gives more stable, or more give you more control on the output, rather than connecting it on pin number 8, because it can sometimes be an issue. Okay, so let's go over here. Let's understand this. So include hash include server that h, which is a library that is utilized for controlling the server. We are controlling the position. We have having a variable with the the keyword server. We are attaching it to pin number 8, and we are adding more variables over here for control. So basically this is based on the tutorial sweep which is present on the Arduino's website. So the whole goal is, we run a for loop. We start from position 0. We go up to our 180 degree, and we do a 1 degree addition on this. So simple things that you need to know over here. You need to know that instead of doing like a pin mode, you are attaching this over here. This attached function and all this function actually comes from the library servo.h, which is present and then handles all these custom functions. So your goal is to write a loop which goes from 0 to 180 with an addition of 1 degree angle. So it's going to rotate up to 180 degrees from starting from 0. By clicking right, you are able to control the angle that is being present. You add a delay so it's more smooth. Then after it have reached 180 degree, what you do is you go down. So you are going to do a minus subtraction of 1 degree, so that you go back to 0 degree, and then you are writing this thing over here like the way you want. And then basically what happens, it goes from 0 to 180, and then it goes from 180 to 0. That's why you are seeing such kind of a rotation motion over here. This is fine. So this does not actually show much of the the analog output. We are going to see one more time. This is fine, but I think one more thing that can be really good is if I'm able to control the angle of this device on demand, because on demand is something which is very much useful for my work. For this, what I'm going to do is I'm going to keep everything the same. I'm just going to change this like this. Okay. And then I'm going to add a serial monitors or a serial begin 9600. So I'm attaching a serial monitor, a serial thing on the begin at 9600. And basically what I want to do is I want to take the input from this serial and use that input to control the position of this servo motor. If you see over here, the code for this thing, you can read the okay, that's the same thing, I guess. Oh, just a second, I think this is the wrong one. So yeah, so the way that you are able to do a serial write, you can also do something known as a serial read. So we can do something like a serial dot read and save it to a variable, let's say POS, and then basically this data is going to be read. When this data is read, it will write to that output over there. As simple as that, but it's a little complex than than a simple serial write. So what we need to do is we need to do one simple change over here. We need to add something known as a serial available. So this is useful only because this is very useful because if the serial is not available, if there is no input, then it might throw up errors. So we don't really want to do that. And let's add this over here. It also have something like okay, let's do that. Now, when we are reading this serial, it might not be in a format that you will be able to understand properly. So what we will do is we will do like a read string instead of a simple read. So it will read the data as a string, which is mostly human understandable. So that's important. And then what we are going to do is we are going to convert that string into a numerical, or something like a number, instead of it being like a a string itself, because Arduino cannot understand string controls like that. So basically I am reading the data as a string from the serial. I'm converting it into an integer, saving it in the variable POS for position, and then controlling the servo based on that. Let's start simulation. Okay. Okay, it's not actually pass int. Let's go with a pass float, because well, it have to have serial. So make sure that you don't make silly mistakes like this. Otherwise, you'll get the error. Again, good thing it tells you what the error is and nothing blows up. So it's all good. Um, let's do a pass float, and that should work. Okay, it's not able to convert it, I guess. Okay, just a second. Okay, yeah, I mean, we can simply do, instead of it like read string, we can easily do still weird, because from what I know, it should be able to easily read it from over there and convert it, but basically it's not able to do that. Super weird. Let's go for a pass int like this. It's been very long then. Pass. Okay, never mind. Let's just read the data and do something about that. I'm just going to do a serial dot println of all the data that I will read, so I know it's there. And then I'll click start simulation. Of course, this requires an in, so let's add a comment. Just a second. Super weird. It's not assigning anywhere. It's still giving issues. I think it's having a cache issues. It's reading data from the old one and then trying to show it over here. That's why it's showing that it's not able to, convert it. Either way, let's get back to it in some time because, we have enough time for that. Let's go ahead and understand the tone melody over here first, which is this is a piezo buzzer that I've connected over here, and through which we are able to generate some kind of a sound. So let's click start simulation. So if you were able to hear the audio, it's some kind of a tone that you can easily hear. If I go to the code, it's quite simple. So again, this is based on some libraries that you have different nodes and you have different node duration. What I am doing over here is, so it's basically providing the output to this device through a function known as melody, which is through a function known as tone, and it's able to generate basically an output which is a form of an analog output. And because of it's in a form of an analog output, it's able to vary its pulses, it's able to vary the different thing, and because of that you are able to get different sound nodes working on this particular thing. Similarly, of course, you can go ahead and uh, you know uh, add like multiple push buttons and a piezo buzzer, so you can create yourself a nice pretty piano that you can utilize for different things. So if you go over here, then you can create yourself a piano where you have multiple push buttons and you have a one piezo buzzer through which you are able to control the sound. Again, this is based on the same principle of the tone, and internally the tone function is used generating some kind of a signal which is in which is a pulse width format, because of which it's able to create a different tone over there. So that's something which is something that you might want to know. Okay, let's move ahead and add some more sensors because we have tons of sensors, and change the output device over here. So the output device over here was a piezo buzzer and a servo motor. Typically what we have seen is this servo motor and piezo buzzer are being controlled through a library. The reason that it is being controlled through a library is it just basically simplifies the whole analog output generations. So that's something that you need to know. But devices such as piezo buzzer and servo motors are are basically controlled are considered actuators, because you can vary different motions about this whole devices. Let's move ahead a little, and let me just remove this one from over here and add a sensor like an ultrasonic range finder, and just understanding about how to interface with different sensors. But it's quite simple. So depending on what sensors you are using, you will find different parameters or different ports. So this have basically three ports. You have ground, 5 volt, and signal. So you have ground, which is connected to ground, you have 5 volt connected to the power supply 5 volt, and signal being connected to one of the ports, the digital ports. Over here, the ultrasonic sensors is basically an input device that you see over here. There are two kinds of ultrasonic sensors present on Tinkercad. So depending on which ultrasonic sensors you are using, both will have different inputs. If you go to the code over here for this, and if you click select for text, these are all fine. Again, this is based on the read ultrasonic distance parameter, which is able to read the function, and this is the ultrasonic sensors, which is doing the same thing over here. So ultrasonic sensors work in simple ways. Basically, they send an output. So there is a trigger pin, which is the signal pin that is there. What happens in this case, basically a trigger, an echo is being created. The signal goes and bounces off the surface and then is being received by that same ultrasonic sensors again. So it generates an echo, it generates this echo, and then it also receives the echo back, and the time duration, and it calculates the time duration. You can calculate the time duration it required for the echo to be received to calculate the distance, because you know the speed of sound, which is quite constant, and if you know the speed of sounds, you can easily calculate how far the sound wave was able to travel based on the reflection behavior. So that's how ultrasonic sensor works. Let's click start simulation. When you click this, you are able to control the ultrasonic sensors. So you are able to make some changes. So basically, if it's within this region, it's able to calculate, as you can see over here, the distance in centimeter and inches. If it's too close, it turns red. If it's within a area, then it's green, because it's able to clearly understand this information. Ultrasonic sensors have a range which is in the form of a cone. So if the object is within that range, it's able to read it. If the object is outside the range of that ultrasonic sensor, it is unable to read it. So sometimes you find ultrasonic sensors with high range and 3D depth and so on and so forth. So it basically controls how far or how wide it's able to see the object. So that's useful in some of the cases. Okay, let's remove this thing. It's actually, let's go with a simple one. Let's go with a simple input device, and let's do it from scratch, so it's all good and clear with us. So let's remove everything from over here. Let's add an Arduino. So we have an Arduino with us over here. Before we proceed, I just want to tell you one of the usefulness of ultrasonic sensors. So of course, many people make digital scales and stuff with ultrasonic sensors, and it's used for in automatic cars that you create, that is able to rover around. But it's very useful in the automatic cars created by Tesla and Google and others. Ultrasonic sensors and infrared sensors and others play a very important role. Basically, these ultrasonic sensors are able to detect obstacle and basically change the path based on different what you can say processing that you require. But one of the fun things that I have built with an ultrasonic sensors for Amazon many years back is something known as replenishment monitor. So what happens basically, let's imagine a big bucket of, let's say, rain, or let's imagine a big bucket of rice. So what happens in this case, when you have a big bucket of rice, imagine on the lid below you are placing this ultrasonic sensors, and on the top you, let's say, have the okay. So let's say on the top and on the bottom of the lid you have this ultrasonic sensors, and on the top, let's say, you have an Arduino. It can be anything just connected to the internet, and then you just close that lid, basically a smart lid or a smart container. So what happens, let's say you have that rice, and depending on how much you are using the rice, different quantities of the rice, you can, measure the quantity of rice remaining in the container. So you can just measure the container once. You know that you feed it to your Arduino, and then when your rice is all filled up, you will know that the quantity of rice is around this much. When the you start using your rice and start consuming the rice, the quantity of the rice in the container starts degrading, going down. With that ultrasonic sensor, you can measure precisely the distance of the rice from the container, and this information can be fed to the internet. Based on this data, you can track different things. You can track what is your rice consumption, how fast is your rice consumption, and if the or rice the quantity of the rice is very low, you can easily reorder or pre-order before the rice replenishes. So you can connect it with grofers or Amazon shopping, and automatically when the quantity of the rice becomes lower than the required threshold, then it automatically triggers an auto shop feature and automatically orders the rice on your behalf. And this can be useful for a lot of things, because it can be used for masalas, it can be used for rice, it can be used for rinse detergent powders that you see, for almost anything that you want. And it just creates a simplified automation, and it's very much useful in the industry, because automation is how industry runs. Without automation, industry will be stagnant. So through this automation, they can order in mass quantities, measure the variation in the different quantities with chemicals. So ultrasonic sensors, you should know, will not work great with water. So for water you have different things, but for chemicals which are dry powder, for example, you can measure the quantity of those things. Another option, people ask me, why don't we use an IR sensor? It's more simple to use and so on. The problem with IR sensor is you are not able to measure the precisely the distance. IR sensor just is more like input and output. It's close or not close. You can just tweak it once. You cannot tweak it dynamically. It's difficult. But with ultrasonic sensors, you are able to measure the distance, and this ultrasonic sensors plays a very important role from industrial automation to self-driving cars. So this it's an important sensor that if you are able to work with properly, then it will be very useful. Okay, moving ahead, I wanted to show you of how to use LDR, or light dependent register. So how LDR works is basically it's a register which whose value changes based on the light intensity, and you see it everywhere. I mean, it's on your auto night light, you see nowadays and everywhere in the city. So it automatically turns on when it's night time, and it automatically turns off when it's daytime. Nobody is manually controlling it, the all the street lamps that you see. And this automation is possible because of the use of LDR. If you go over here and if you go to the input devices, you see you have a photo register, which is again the LDR. You have ambient light sensor, and you have photodiode. They almost do a similar thing, only the output data that is being provided by them are in different format. So you can choose whichever you fancy. It's up to you which one you want to utilize for this your use case. Working with LDR is very simple. Nothing fancy is going on over here. So it has terminal 1, terminal 2. It needs a register. So let's add a register over here. You can rotate it using this function. Let's rotate it. Uh, let's connect it to, let's say, 5 volt, and one of them will be connected to ground. If you even reverse it, it's fine. It's not a issue at all. Now this device is an input device. First you need to understand that it's an input device. Once you know what kind of a device it is, you can connect it automatically wherever you want. So basically I'm going to connect it to A0 for reading the analog over here. I'm going to go to text, and there is no output over here. Let's go for A0 as input. Again, not very important, but a good thing to have. Let's add a serial dot begin 9600. Let's do a analog read A0. save it in a variable sensor value. The default is 0. Let's save it over here like this. And then let's print it out. Serial.println sensor value. And let's click start simulation. So it works pretty much like the the potentiometer that you have seen. Let's open the serial monitor. By default, it is giving you a value of 6, which is the minimum. So not all of them will have a minimum of 0. And what you can do is you can vary the intensity of the light by selecting this. By varying the intensity of the light, uh, you are able to see the output on the serial plotter as well as on the serial monitor. This is very useful. Now what we are going to do is, I'm just going to keep it like below over here so we are able to see this. It's a little less space. Okay, now what I'm going to do is I'm going to add pin mode 13 as output, and then I'm going to add an if else statement. So I'm just going to print it because I need to print it. So it looks good. We add sensor value. If sensor value is beyond a threshold, let's say 400. Okay, I'm following up different syntax over here, and then else, and then you do a digital write on pin number 13 as low. Typically go like this, and then you are doing a digital write on pin number 13 as high. Okay, so let's start simulation again. This is pin number 13, I reiterate. So currently it's off because the value of the sensor is below 400. When I increase it beyond a threshold, beyond 400, it automatically turns on the light. It's giving the output high because it is on now. So you can see the variation over here. So it goes from 0 and it's on the current value of 600. So the variation is clearly to see. And because of this if and else statement, and you have set a threshold, you are able to control that light that is connected on pin number 13 by default. If you of course reduce the intensity or of the light, then what happens? The LED turns off. So it's a simple circuit but used everywhere in the city for the auto night light or auto street lamps that you see, and it's based on this very simple principle. And on pin number 13 you can connect almost anything that you like. So it's up to you. It can be a bulb, it can be anything, it can be a relay. So a bulb is usually controlled to a relay, and once you are able to do that, then everything works as expected. Great, so that's awesome. Let's learn how to use something known as an LCD. So LCDs are great. It's awesome because you typically use it to show the output. You are not going to always show the output to the external users in the form of serial monitor. They even won't have access to a serial monitor. So LEDs are very useful in this case, and LEDs or any devices like this are great for showing the output in any way that you want. So let me add it over here. Just need to center it. Great. So it might look like a complex circuit, but if you already have it in your starter kit and it's already there in your starter kit, you don't have to worry so much about it. This potentiometer is nothing but to you to change the intensity of the light coming from the LCD. Nothing fancy going on there. Let's click start simulation, and let's wait for it. It just prints hello world over here. Very simple thing, nothing fancy going on. And it's, I think, increasing on a per second basis. All good. Let's go to the code. Let's not go into complications. It's a pretty simple. So LCD begin. So its begin is very important. 16 by 2. The 16 by 2 is nothing but number of columns and rows. So 16 columns, 2 rows. So depending on different LCDs, so there are different LCDs with different columns and rows. You can control this. And you're printing hello world over here. Simple LCD print hello world. You can change the cursor. So the cursor by default is on 0 0. So 0 0 is first row, first column. When you set the cursor to 0 1, so what will happen, this is first column, row second, because 0 is the index, starting index, so 1 means the row number 2. And then you're basically printing the millis, or the time over here divided by 1000. So it's just basically printing the time every second, so it's automatically iterating on that. We don't want that. Let's remove this. Let's do Tinkercad, and let's start simulation. So you can see it's pretty simple. All you have to do is use the display function, and you are able to show the output on this LED very easily. Now let's dive in. So I have made a fun thing before. I call it crystal ball. Okay, so I'll just show you. Basically, it's based on the LED and the processing of Arduino. It uses arrays, so it's able to randomly select a value from the array based on the random library of math library, random function of math library, and able to show something like a random text on the LCD device. So it's pretty useful. It's very good for many use cases. And I'm just going to show you this a pretty neat thing that you can do with LCD. Hopefully it just loads up soon. Just guess working. I think it's my internet today seems a little slow. I think it's sending out the videos and sending out the audios and streaming and everything. It's got to be pretty slow. I'll just open a couple of circuits so that we have it running in some time. Super weird. Probably I try to disable my video so that it gets some speed, I guess. Just a second. Wow, it's okay, loaded up. Cool, great. So yeah, this is like a crystal ball thing that I've created just based on LED and Arduino. So if you click start simulation. Oh wow, okay, great. Then I do again. Wow, I got a nice one. Mary heart is good. Okay, then I click this. Okay, it's repeating. Probably try again and seize the day. Great. So how does this work? It's able to print different messages. So like I said, it basically works. You just add an LED, and then you basically add like array. So to create an array, you add the type of array string, and then you add different things over here. Promotion is you will soon, laughter is the live live long. And so I've added a couple of you can say in strings in the array. So I have two arrays. So basically what it does is, so it randomly select one of the message from the first array and randomly select one of the message from the second array and shows them on the row 1 and 2. So you basically get a message something like a promotion is be happy, a promotion is best medicine, a promotion is prosper, and so on. So basically you get like a crystal ball fun thing. I'm able to do like a random seed because of the random generation. So random 0 to 1, it's basically going to generate a random value between 0 to 10. Uh, it, 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 uh, it depends on how many variables, on how many elements you have in your array. So you can select it automatically. I'll clear the LED. I'll set the cursors on the first row, first column. I'll print the random string. First column, second row, I'm going to print the random string. So that's it. What's gonna do. Very simple but very fun. So you'll soon be happy. I hope that, and live long and prosper. So it's so simple. All you have to do is add that LED, add some code, and you have a running crystal ball. The more thing that you add over here, the more thing you can do with that. The good thing is you can interface. So LCD is basically an output device, but you can interface it with input devices such as let's say an accelerometer. I don't know if you know this or not. There used to be a very hit device in the market known as 8-ball magic. So what happens? So 8-ball is like a snooker ball, big snooker ball. If you play snooker uh, or pool, people like to call that it pool as well. So it's basically a big snooker ball and the LCD on the top of it. And then you just shake the the snooker ball, and and it's able to generate such random messages. The way that it works is basically have an accelerometer sensor inside. When you shake that 8-ball magic 8-ball, it basically detects that and automatically based on that randomly generates a string. So it's a fun game and pretty good game. You use for truth and dares, used for facts, used for fun things, and so on and so forth. It was a bestseller in USA market, so it's gaining a lot of, I can say, money because of that. But the whole thing is very simple, nothing going on fancy. Basically, there's a microcontroller inside, there is an LCD, and there is an accelerometer sensor, power, of course. Apart from that, nothing else from the electronic side. It's so simple, but it's pretty much garnered a lot of users, and people are still using it for fun cases and for camp night and so on. So it's pretty useful thing that you can build very very easily through such simple components. So I wanted to show you that with LCD. At the same time, I have created like a little complex thing. Let's go in that. But before we go in that, I want to show you about the RGB LED first. Just going to. So RGB LED is pretty simple. What it does is basically 3 LEDs combined into one, because so you are able to control the red, green, and the blue lights, because of which you are able to control the LED color. So you click start simulation, and it's able to turn it into different colors because it's running in a for loop. So RGB LEDs are pretty simple, nothing going on over here. You are connecting the cathode to ground like usual, and all the other terminals goes to one of the input ports or the digital ports through a register. In the code, basically I'm having all those red, blue, and green pin. I'm running a loop where I am setting the color differently, set color 25500 and so on and so forth. So basically it goes from red to green to blue and so on. But you can vary it accordingly to what you want. So RGB LEDs are great. So you can create awesome mood lamps based on this RGB LEDs. Again, a device which is selling hot in the market. If you can create it, it's all about the external look and feel of it. But the electronics is very simple. What I've done over here is I am using an RGB LED. I have some potentiometer, and I have the LCD over here. I'll use the LCD to see the input given by that potentiometer, And by changing the value of the potentiometer, I will be able to change the color of the LED, or basically set the mode for the, for the device. I'll click start simulation. So basically it's at 159, 164, 255, and then you can see it's kind of like green. I'm just going to vary this. So you see this both are 255 now, and this become like a teal blue color. I'll vary this over here as well, and you can see this is now 1. I'll reduce this and reduce this. So you can see it's again more like green over here. If I turn this all around, then it's kind of like orange color. So depending on what I want, depending on the knob that I'm rotating, I can control the, the value of the RGB LED. And on the LCD, I can easily see the value, which is useful. It's just a fancy way of serial debugging, but it's pretty useful to understand how to interface with LCD input devices, which are the potentiometer and output device, which is in RGB, which is pretty much useful for a lot of cases to get a whole understanding about this whole thing in one go. Again, I just want to iterate on the components which are available, which is pretty much useful for a lot of use cases, and cover probably one more, so you are able to understand how it is working. I'll stop the simulation. I'll go and consider the input devices. Push button, cover, potentiometer, photoresistor, all this are same. Slide switch and push button are about the same. Flex sensors. So basically how this works is, this is useful, auto control arm. People are usually using this when they want to create robotic arms. So flex sensors basically detects, it's basically a registers whose value changes depending on how flexing you are doing. So how much pressure you are putting on that flex sensors by twisting it, and so on and so forth. IR sensors are like IR sensors useful a lot of ways. Ultrasonic sensors, like I said, they have two ultrasonic sensors. This blue one is usually used more often than the teal one. PIR sensor is for human presence detection. Tilt sensors is utilized for detecting tilt, whether it's tilted towards certain angle. It's another kind of tilt sensors. Temperature sensors, CM3, so detecting temperature very easily. You have the gas sensors, detecting gas. Keypad is used often, so we are going to use keypad and see. So keypad is very useful if you want to create like a security lock or something. You need to allow them to give an input in the form of different things. DIP sensors we have. Output devices we have covered pretty much everything. New pixels are just fancy LEDs. Servers, so these works almost in the similar format. DC motors work a little differently, but it's pretty useful if you want to go that way. You have piezo buzzers. You have IR remote. IR remote probably is like input sensors. It should not be over here. Uh, yeah, and then you have the 7-segment display, which is an output device. Pretty much used mostly you have seen it in lifts, so pretty much useful in those cases as well. So let's go ahead and try to interface the LCD or 7-segment display with the hex keypad and see how it works. Hex keypad again is based on the push button principle, nothing fancy going on over there. So hex keypad. I'm just going to open up the circuit right now so we can have a look at that. Okay, I'm waiting for it to open. Let me just open it over here. Yeah, one thing you should notice, you can definitely not use Tinkercad on your phone because drag and drop won't work. If you have a tablet device, then it will work properly. But definitely don't try this on mobiles. A desktop or laptop or tablet is preferred for working with Tinkercad because of the whole drag and drop thing that you see. Little slow, but I'll just try to add this. If only I can add that. I'll share another screen instead where I already have this running. So, it works like that. Okay, so we have this over here. We have the Arduino, we have the hex keypad, we have the LCD. Again, like I said, potentiometer does nothing. It just controls the intensity of the light of the LCD. In the code, you are adding the. So there are keypad libraries that are available like keypad.h and liquidcrystal.h, which allows you to simplify the whole code and easily control it. There are 4 rows and 4 columns. Like, as you can see, there are different hex keypad available with different requirements. So you need to configure that. You are adding what keys does what. You are basically adding those keys as rows and column, a two-dimensional array if you want to call that. Basically what you are doing is now you are using the keypad library function get key to get the key. You are saving it over here. If the key exists, if it does not exist, then you need not show anything. If the key exists, then you are printing it to the serial. But the main thing is you are printing it to the LCD over here like this. Let's click start simulation. So I can do like click A. I can click 1, 2, 5, 6. So, and you can of course keep on adding more. So basically the code is just adding adding the to the column and allowing to take the input from the hex keypad. Basically two important things: get key, which gives you the data, which is the key, and print LCD.print, which prints on the LCD. Nothing fancy is going on there much, but it's pretty useful because you can utilize it for different purposes. So this hex keypad can be utilized, like imagine a lock or safe that you have created for yourself, and then you have your secret diaries or anything over there. And then what you do is you add this keypad, and then you lock it, and then whoever enters the proper password and let's say click hash for as an enter key, they are able to click open the lock. uh, this is also very useful in recent days for device timers. So this is pretty much very useful in device timer devices, which is gaining a lot of transaction these days. So basically how this works is basically a jar, transparent jar. Imagine a big transparent jar, okay, and you add your phone inside it or any devices which might distract you. So this is very useful by parents. So parents, what they do is they take their their children's, especially small children's devices, let's say during food time or any family time, and they keep those devices in their box, in that transparent box, in that transparent jar. They lock it, add a timer. So basically what happens, they add a timer through let's say hex keypad. They can see the timer and they click and they close the lid and start the timer. Basically what happens in that case using servo motors is basically what you can say, shut down the lid very tightly, locks the lid. Let's say you have kept a timer of 60 minutes or 1 hour, and during that 1 hour it will not do anything with the lid. You cannot open the lid. You can try everything that you want, but it will not open the lid. Once the 60 minutes are up or your timer is up, the lid will automatically, it will automatically through the help of servos, basically, allow the lid to be open. So it allows people to have, quality family time without distraction of, this medias or mobile phones and so on and so forth. So it's pretty useful and a device which is having a lot of, usefulness. The working is pretty simple. It's based on LCD or, any output device for displaying the timer so that they know what they are setting. Input device such as hex keypad for setting the timer to what they want. A servo motor for locking, for using for the locking mechanism, and a simple microcontroller. It can be at tiny, it can be the PCB version of Arduino or anything. and pretty useful device that you can sell easily and market easily, and a very useful project, but a very a project that is having a vast impact and is being utilized everywhere. So that's pretty much it that I wanted to show you around of what everything is present on Tinkercad, how to work with Tinkercad, give you some basic ideas about input and outputs of how the processing can happen, give you some real life example of how this can be utilized for working with real working on real projects. I usually recommend to start with Tinkercad, do your simulation, get that idea rolling, see if it's working as expected, do the coding, make mistakes, and make sure that it works as expected. Then you can add the as Pravinsa will also be taking in the next day of how to connect it with the Internet of Things and so on. Once you are very comfortable with the whole environment, the next step that you can do is you can order those devices, you can make a physical system, copy the code, use the same wire connections, because once you know how it works, you can say make the same wire connection. Better yet, you can also order a PCB if you want directly. You can export your code in different formats such as BRD, which is used by Eagle PCB, and then you can get the PCB ready as well, do the connection as and when required, do the testing, and everything. If it works as expected, you can get your project at product out there and have it working. But Tinkercad is going to be the first step where you are going to perform all the simulation, the proof of concept. The proof is in the pudding, as they say. Share it with your friends and family, let them tweak it, let them see how it works, see if they like it, and then you can have a final product which is going to be awesome and great without all the unnecessary burden and cost of getting started. Which is simplified through the simulation environment, which is Tinkercad. So thank you so much. I hope this was a fun learning thing that you had gone through. Uh, Little hiccups here and there, but that's fine. I mean, it always happens, so that's cool. Let me know if you have any doubts, any queries. I am keeping it all open for any doubts and queries that you might have, so we can take it one by one. I see the chat around if there is anything that I might have missed. But apart from that, let me know. Pravinsa, all to you, and you can allow for the question and answers over here. Thank you so much. Thank you so much.
Yeah, thank you, sir.
Yeah, thank you, sir.
Now I request
Now I request
participants to have their questions to our today's speaker.
Can we integrate?
Yes,
Yeah,
sir,
I
yes.
think there are some of the questions. Probably I start answering them. Give me a second. Okay, so many conversation. Glitch. Connections. Okay, integrate a deep learning algorithm and Arduino. Oh yeah, I mean you can. Arduino is Arduino Uno R3 Revelation 3 or version 3. There are different Arduinos that are available, Leonardo and Duo and so on and so forth. Lots of microcontrollers, where you can utilize machine learning algorithms. There's a library known as TinyML, which have been developed by developers, which is useful for integrating machine learning on Arduino itself. It cannot do big complications in the processing, is typically a little slow, but it's very useful. So you can use this for working with accelerometer sensors, or working with other data. This thing is known as edge computing. When the machine learning or the computing or the deep learning happens on the device itself, it's known as edge computing. When you send the data to the cloud and then the processing or the machine learning happens on the cloud, it is known as cloud computing. So that's one difference that you might want to know. Edge computing is great because it preserves privacy, it's more faster, it's more secure, faster in the sense compared to sending data to the cloud and so on. So it's something that you want to pursue. Devices such as Raspberry Pi, Intel Edisons, and there are Intel sticks that are available. Even on Arduino, you can perform pretty much vast variety of machine learning such as regressions and classification algorithms very easily using the libraries that are available. So it's something that you might want to check and see. Another question that I see is um, can a heavy electrical device yeah, of course, you use a relay. Arduino can control relays, and relays in turn can control any heavy device that you want. So the main concern is not about the Arduino. The main concern is about the relay. The relays will be of great what you can say quality, depending on what you want to control. So if you're controlling fans and lights, then typical relays you get in the market is fine. But if you want to control ACs, air conditioners, or washing machines, or something which requires a lot of power and so on, so you need to select the relays accordingly. For industrial appliances, you need to select the relay uh, accordingly, and the power source and everything. Arduino is just a control device. It just requires 5 volt. Even TCS use a one version of Arduino for some of the projects that they work on for the prototyping, where they for the electronics project that they get, where they are using Arduino for quick prototyping to control different devices. Then they convert it into an FPGA for working with such electrical devices. For IoT application which CPU platform is suitable, I think Arduino is great. There is also Node MCU, which is basically very small but very powerful, that you can combine with like Arduino, and instead of using Arduino and ESP8266, you can use Node MCU directly. So it's pretty powerful for a lot of things, but it depends on what application you're talking about. For IoT, there's so many in the market, you can easily find them. Sometimes some condition statements simply on void setup, but generally or normally on void loop. So it's generally on void loop. Like I said, so void setup is only run once, and void loop is something that runs continuously. So usually all the conditional statements are go in the void loop. Void setup, sometimes you add the conditional statements depending on different parameters. So sometimes you want to check the data first in the first go itself, what the data is, and then allow people to proceed further and so on. So depending on your use case, you might want to put it in void setup as well, but generally it is in void loop. As you said, there are various logic gates, but can we add any other ICs which we need but not mentioned in the components? Currently, no, you cannot add other ICs which are not present in the Arduino components. Tinkercad or Autodesk is trying to add more components. At a later stage, it will be possible to add your own components through the form of code, the component coding, but it's pretty buggy right now. So it's in the work, but right now that's not possible. Right now, hopefully later you will be able to add that. This is one of the major difference between other simulation softwares and this softwares. Is Tinkercad is you have vast variety of options, but you cannot add more by yourself. In other simulation softwares, you can write the code for the component and add it. But again, that's a very complex and advanced level thing which you cannot directly do either way. So that's fine. Agriculture field, huge. It's like it's having a huge demand. I mean, I have a garden at my terrace. I cannot really go right now to show. So I use this, electronics for controlling the gardening. So I have in lockdown, this is my hobby. So it's gardening. So I have a couple of pots, different things, aloe vera, rose, and homegrown fruits as well. And all of them are connected to small pumps. You can easily get it, and then all of them are connected. So you can imagine 10 of those you can say pots, and then all of them are connected through pumps and to like a water area, and then all of are connected to Arduino. Through automatically, what happens, it after a threshold, after a certain time, whatever have been coded, it automatically waters them from time to time, so they are able to work on that. And with IoT, what you can do is you can have control of these devices. You can water them accordingly, depending from your control, from your control panel, which you can have from your phone or website and stuff. So that's pretty much useful. Agriculture have huge demand for all of this, for IoT and embedded. Arduino board, that's something that Praveen sir will be covering, I think, tomorrow, where you will be able to control devices using app and Arduino using the IoT Internet of Things. Like I said, I think you cannot add more input devices which are currently not present on Tinkercad, but like I said, it's in the works. More devices are being added from time to time. In the meantime, you can experiment with what's already there. Can Arduino be used in different programming languages? Technically, no. It needs embedded C to work with, but there are softwares which are available which convert the coding from, let's say, your preferred language into embedded C. So for example, you can write a code in Python, which is very preferred, and it will automatically convert it into embedded C, which you can, put it, feed it to your Arduino. Arduino itself needs to work in embedded C, but Python or other languages can be utilized, but you need an IDE or integrated development environment that will convert that Python code into embedded C for Arduino. Okay, great. I see no more questions now, so I hope all of it is clear. I hope this was pretty informative and
Hello,
you
sir.
were
Good
able
morning.
to. Hello, sir. Good morning. Yeah, good morning.
Sir, can you describe a little bit about servo.h library?
Servo that .h library. Okay, so basically, I don't want to go much technically in it. So library, I'll tell you basically how library works. It's nothing but embedded C code, but have been specifically written by the manufacturer or developers, freelance developers or indie developers who want to work with that library. The way that works is there are different functions written which perform different things. So there are different so it basically comprises of advanced codings, like arrays and pointers, and they are able to index. So all the devices, basically what you're seeing, the pins 1 2 3 and so on, have internal addressing as well. Through internal addressing you are able to do a lot more things. So when you work on the register level, so the server.h library and lcd.h library basically works on the inner level or on the register level and is able to control different things. And when you add it in the library in the form of a library, you are able to expose some functions, such as controlling the direction, controlling the angle, and controlling the speed, while you don't have to worry about going deep into working of the register itself and the other things. So that's what the library does. A servo.h library and some of the library are directly available in Tinkercad, but like I said, you can include your own library as well, create your own libraries if you want. So .h format is the header format when you create libraries. So that's one thing about it. Internally, it's huge amount of code, so we cannot technically right now go into it.
Okay, got it, sir.
Thank you, sir. Is there anyone who would like to ask any question to our speaker? I hope most of the questions asked by the participants are answered by our speaker. So I thank Mr. Anand Satyapal for his knowledgeable session. Hope this will help all the participants to go with the Tinkercad to teach and learn the Arduino. Tomorrow we'll learn how to send the data to any of the cloud, and we'll try to take some cloud data in your mobile app. So a complete IoT system we will try. So as a token of love to our today's speaker, I'd like to share one soft lack of appreciation. So this is from our IEEE student branch, SGMC. So IEEE SGMC student branch would like to thank Mr. Anand Satyapal for his support during this workshop and the session on sensors, actuators, interfacing with Arduino to Tinkercad. I thank from our student branch and the Sri Santarajan Maharaj College of Engineering. Thank you, sir.
You're welcome. Thank you so much for having me here.
So with this, now I say this today's session is over. Tomorrow we'll meet at 10 a.m. again. And before that, I'll try to share some of the today's examples to you so that we can use them in tomorrow's session. Thank you, all the participants. Thank you, sir. So now
Okay,
I'm going
goodbye
to
everyone. Have a nice day.
yes, sir. Yes, please. So now I'm going to close this today's meeting. Thank you all.